Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. Today, we're diving into a pretty provocative article that really got me thinking: hype, sustainability, and the price of the bigger is better paradigm in AI.
Excited to unpack this. It's a conversation we need to be having, especially with all the recent breakthroughs, or at least perceived breakthroughs, in AI.
I'm interested to see where this goes. The bigger is better mantra has always struck me as, well, a bit simplistic, honestly.
Yeah, I agree. It's like we're building these massive digital skyscrapers, but are the foundations actually solid? Are we solving the right problems?
Exactly. And that's what the article touches on, right? Are we truly making fundamental progress towards AGI, or are we just creating increasingly sophisticated mimics? The hype is definitely outpacing perhaps the reality.
I think the hype is justified, to a degree. Look at the progress in large language models. The ability to generate coherent text, translate languages, even write code, it's astounding. It all comes down to throwing more data, more parameters, and more compute at the problem, right?
That's precisely where I disagree. It looks astounding, but is it actually understanding? These models are essentially statistical pattern matchers on steroids. They can generate convincing text, but they lack genuine comprehension. It's like a parrot reciting poetry. It sounds beautiful, but there's no actual understanding behind it.
I'm with Sarah on this one. Think about how these models handle spatial reasoning or temporal sequences. They struggle. They're trained on static datasets, but the real world is dynamic, constantly changing. They don't really grasp the relationships between objects in space or the flow of events in time.
That's a great point, Donald. And it ties into the sustainability aspect of the article. Is this bigger is better approach actually sustainable in the long run, not just environmentally, but also intellectually? Are we hitting a wall where the gains become marginal and the cost in terms of energy, resources, and even just research time becomes prohibitive?
Okay, but let's be fair. The energy argument is valid, and there are definitely environmental concerns, but researchers are actively working on more energy-efficient architectures. And the idea that these models don't understand, well, how do we define understanding? They can answer questions, solve problems, and even generate creative content. Isn't that a form of understanding, even if it's different from human understanding?
It's a simulacrum of understanding, Otto. Think about the famous Winograd Schema Challenge. These are simple questions that require common sense reasoning, something a child can easily answer. Deep learning models still struggle with them because they lack the underlying knowledge representation and reasoning abilities. They rely on statistical correlations, not actual causal understanding.
And it's not just about common sense reasoning, it's also about adaptability. These massive models are incredibly brittle. They're trained on specific datasets, and if you deviate even slightly from that distribution, their performance plummets. A truly intelligent system should be able to generalize and adapt to new situations and translate between representations. Something current deep learning struggles with.
Exactly. It reminds me of that old saying, to a man with a hammer, everything looks like a nail. We're so focused on deep learning that we're trying to force everything into that framework, even when it's not the right tool for the job. The article suggests that we need to step back and reevaluate our fundamental assumptions about intelligence. Maybe the answer isn't just more data and bigger models, but a fundamentally different approach.
Okay, I'll concede that there are limitations, and the energy consumption is a serious issue. And yes, the brittle nature of these models is a concern. But I still believe that deep learning is the most promising path towards AGI. We just need to keep pushing the boundaries, developing new architectures, and yes, feeding them more data. We're seeing emergent properties that we never anticipated. That's got to be worth something, right?
Emergent properties, sure. But are they meaningful, or are they just statistical flukes? I think we need to explore alternative approaches, like neuro-symbolic systems. These systems combine the strengths of neural networks with symbolic reasoning, allowing them to explicitly represent knowledge and reason with it. It's a more principled approach, and it aligns better with how we think the human brain works.
I'm leaning towards neuro-symbolic as well, or something even more radical. We need to find an algorithm that can inherently understand space and time, that can translate between different coordinate systems. Think about how we navigate the world. We don't just process pixels, we build a mental map of our environment, understand distances and directions, and plan trajectories. Current AI just isn't able to do that in a robust way.
That brings me back to my own thinking about drawing inspiration from neuroscience. If we look at how brains evolved across different species, we see different solutions to the problem of intelligence. Some rely more on instinct, others on learning, and still others on complex social interactions. Maybe by studying these diverse approaches, we can gain insights into how to design more robust and adaptable AI algorithms. It's about understanding the principles of intelligence, not just replicating the structure of the human brain.
So you're suggesting we look at, like, insect brains for inspiration?
Actually, that's not a bad idea. Insect navigation is incredibly efficient given their limited neural resources. They solve complex pathfinding problems using relatively simple algorithms. It could offer clues to how to achieve robust spatial reasoning with less computational power.
Yeah, and think about the embodied cognition movement. The idea that intelligence isn't just about what's happening in the brain, but also about how the body interacts with the environment. We need to build AI systems that are grounded in the real world, that can learn from experience, and that can adapt to changing circumstances. That's something deep learning currently struggles with. It is all based on static pre-existing datasets.
Precisely. It's about building systems that can not only process information, but also act on it and learn from the consequences of their actions. The article mentions the importance of feedback loops, and I think that's crucial. We need to move beyond static input-output models and build dynamic, adaptive systems that can interact meaningfully with their environment.
Okay, I'm starting to see your point. The focus on bigger might be blinding us to alternative approaches. But I still think deep learning has a role to play. Maybe it's not the only answer, but it's a valuable tool in the toolbox. We just need to be more critical about how we use it.
I agree. Deep learning can be useful for certain tasks, like pattern recognition. But we need to be honest about its limitations, and we need to invest in alternative approaches that address those limitations. It's about finding the right balance between statistical learning and symbolic reasoning.
And it's about understanding the underlying algorithms that govern intelligence. We need to move beyond brute force computation and find more elegant, efficient solutions. That means exploring new mathematical frameworks and drawing inspiration from diverse sources, including neuroscience, embodied cognition, and even insect behavior.
Okay, so if we were to each suggest a future research direction based on this conversation, what would it be? Sarah, let's start with you.
I would advocate for more research into neuro-symbolic AI. Specifically, developing algorithms that can seamlessly integrate neural networks with symbolic reasoning engines. We need to build systems that can not only learn from data, but also represent knowledge explicitly and reason with it in a transparent and explainable way. I think we need to look into improving knowledge graphs to make reasoning more effective.
I'd say we need to focus on algorithms that can inherently understand space and time. That means exploring new mathematical frameworks for representing spatiotemporal relationships and developing AI architectures that can seamlessly translate between different coordinate systems. We should be looking at how the brain does it, sure, but also explore entirely novel computational approaches. Maybe even quantum computing could unlock new possibilities.
I'd suggest focusing on improving the efficiency and sustainability of deep learning. That means developing new hardware architectures, exploring more energy-efficient algorithms, and finding ways to train models with less data. We also need to develop better evaluation metrics that go beyond simple accuracy and measure things like robustness, generalizability, and explainability. The work with pruning to reduce the size of models will also assist us to improve the efficiency of deep learning.
Building on that, I think we need to invest in interdisciplinary research that brings together neuroscientists, computer scientists, and engineers. We need to study the brain not just as a collection of neurons, but as a complex system that integrates sensory information, motor control, and cognitive processes. By understanding the principles of brain function, we can design more intelligent and adaptable AI algorithms, especially focusing on the brain's ability to adapt to new conditions and learn new tasks without catastrophic forgetting. That's something current AI really struggles with.
Okay, that's a solid set of directions. I think if we focus on these areas, we can make real progress towards AGI. Even if it's not the AGI that everyone envisions, it'll still be a significant step forward.
Agreed. It's time to move beyond the hype and focus on building truly intelligent systems, not just impressive statistical models.
Let's build something truly groundbreaking that solves real problems in new innovative ways, rather than just keep scaling up the existing models.
Absolutely. It's about building systems that are not only intelligent, but also sustainable, adaptable, and aligned with human values. Thanks for joining this conversation. That's all for this episode of Cognitive Spirals. Join us next time as we delve into another fascinating topic at the intersection of mind and machine.